So now, earlier classes, that means the previous classes, were discussed about the prepositional logic. Okay. So, for today class lectures, we are discussing about first order logic. First order logic. Okay. So what is the difference between propositional logic and first order logic? The basic difference is that now propositional logic is also called a first order logic, but some limitations. We cannot explain complex sentences in the propositional logic, so we can move forward to the first order logic. Okay, same thing. Here we can also discuss about fact. We can also discuss here rule. We can also discuss here an inference rule. Okay, the inference rule. This is all the things we are going to discuss again one by one. Okay, but here the symbol, I'm talking about the symbol, a little bit different, but more or less same. Then we are discussing about the syntax. Okay, and here we can discuss about the semantic. So these are the very important terms of the first order logic. Okay, so again in the first order logic we can also apply tautology. So what is the meaning of tautology? All true. Okay, then we can also apply the contingency, uh, what is called consistent, consistence. So this is the false. Okay, these are the terms we can also use in the propositional logic. We can also use in a first order logic, like tautology, consistence, symbols, syntax, semantics, fact, rule, and inference rule. Okay, now here uh, in propositional logic, what we are discussing about the relationship. Okay, relationship. Okay, but here we can use the new terms is called as a predicate. Okay, so here we can use the new terms name as a predicate. Okay, so here we can call a relationship as a predicate. Okay, so don't be confused what is the predicate logic, what is the first order predicate logic. So sometimes it also called as a first order predicate logic. So sometimes it's also called a first order predicate logic. So don't be confused what is the first order logic and what is the first order predicate logic. Both are the same. Okay. Now, these are the terminology we are going to discuss. What we are going to use in the next lecture. That means, so don't be confused when we are writing the sentence and we are not found. So here we can also use object. Okay. Here we can also use function. Here we can also use concept the relation. Okay, relation. So these things are already we study in a propositional logic. The object, so maybe a people, number, a and b, word, theory, anything, square, feet, all the things. And function we can say that the best friend of, okay, the third friend of. So something writing with of is called as a function. That's relationship, father of, okay, brother of, sister of, that is called as a relation. Where the point is that where the of is written, where the of is written, that means a relation is established. Okay, relation is established. Wait, relation is established, that is meaning. And what is the function? That is the I'm sorry, this is the function. I'm talking about function, not a relation. If something is written with the father of, brother of, sister of, dash of, that is called function. And relationship, that means we can say that we can establish a relation, that means me and my brother, so that is a relation, we can say that. And object, the suppose I'm writing x is a real number. Okay, now x is a real number, that means x is a object. X is a object, and this is the number. Number is a relation. Okay, number is a relation, And what type of relation is a function type? You can put as a real number. Okay, is it clear? So now x is an object. Okay, now so x is a object now, and this is the relation, and this is the real. So this is the we can find out. So don't worry, we cannot using like all the time. So these are, and in the syntax I'm going to discuss about the syntax. Okay, so now see what happened for your exam purpose. They will ask you in one number question what is the symbol, what is the syntax, what is a semantic, this type, what is the predicate, what is the logic, what is the propositional logic, give me an example. So this type of questions they can frame. So don't worry. So based upon your previous knowledge, that means you work as a KB, knowledge based agent, and perform the task. Very simple. Based upon the previous knowledge and perform the task. Okay. So this is the way. So we all are acting as a knowledge based agent. Okay. So this is the process we can follow. Is it clear? Wait. Wait. I need to change the background. Okay. So don't be confused. This will be the black. I need to be changed. Okay. No. See. Okay. Na? So these are the we can say that. So this I am writing symbol. This will be the syntax. This will be the semantic. This will be the tautology, consistence. Uh, this will be the fact. This will be the rule. This will be the inference, and these are the relation. Okay, so these are the things. Okay, so point is that we can study about the first order logic. Okay, so then what is the syntax? So someone asking you what is the syntax? So don't be confused. Syntax is a collection of symbol, is a logical expression. That is a syntax. We can say that. Suppose someone asking what is a syntax. So we can say that syntax is a collection. Syntax is a collection of symbol, okay, in a logical expression. In a logical expression. Okay, so that is the symbol. That is a logical expression in the first order. So we can say that is called the syntax. Okay, so syntax may be like what is the syntax. So suppose someone asks you, can you explain with the example? So we can say that the symbol. So it may be x, y, z. So that is a part of variable. That is a part of variable. Okay, x, y, z. That is a symbol. Now, so suppose someone asking this is the constant, also is a symbol. So constant you can write like one, two, a, anything. Name of like cat, dog, Pankaj, any Marwari University. These are the constant. And function. So connectivity. I'm talking about the connectivity. This is a very important connectivity. So it will be the what is the conjunction, disjunction, negation, implication, biconditional. These are the connectivities. Okay, and we are talking about the equality. These are the part of the syntax. Okay, equality, that means we can refer as a equal to equality, and a quantifier. Now quantifier. Okay, so quantifier we can express as a all, and this is the we can opposite of e. These are the quantifier. So what is the meaning of quantifier? Now suppose in a propositional logic we cannot define all, some, and this type of activities. Suppose I want to write all men drink coffee. Yeah, like, so how can explain with the help of propositional logic? This is not possible. Okay, It is not possible. So for that purpose, we can use the quantifier. The quantifier, this is for all, and this is for some. Some, that means at least one, at least one. Okay, this is represent as a all, and this quantifier, that is the therefore. Okay, this is all, and that is called a therefore. Okay, so therefore, that means there exists some. Okay, that means we can say that among class some students are intelligent. Okay, that not mean that all students are intelligent. Some कुछ लोग ही intelligent है. So we represent as a this one as this. Okay, so this is the way we can represent a quantifier. So these things are very important. Okay, so don't be confused. Now see, so we can use the predicate on the atomic and complex sentences. So you know what is the atomic. So now see, these things are already discussed. So atomic and complex. So these are the key points. So what is the atomic? So atomic, that means a single sentence, that is a simple, and complex addition of two atomic sentences. Now see what is the atomic. So suppose my name is Pankaj, so that is the atomic sentence. Or my name is Pankaj and I live in village. So that is the complex sentence. So this way. So these things we can represent as a predicate and logic also. So now, this is a discuss about the quantifiers. So quantifiers are language generator quantification. We can say that. So first one is called as a universal quantifier, and second one called the existential quantifier. Okay, first one is called as a universal universal quantifier, that is also called as for all, or we can say that everyone. So that is the meaning of universal quantifier and everything. Okay, and the second one we can call as the existential quantifier, that is called for some. Not is not all, for some, or we can say at least one. At least one. Okay, so these things are going to use. And now, so I'm discussing about one by one universal quantifier and existential quantifier. So that is therefore, and now see. So first we are going to discuss about the universal quantifier. So these things already studied in the DM. Don't be worried. Universal quantifier. Okay, so it can be represented as a like this one. So this can be represented as V, and we can cross. So that is the symbol. Okay, this is the symbol for the representation of the universal quantifier, that is meaning for all x, for each x, for every y. Okay, so that is the meaning. And now where the universal quantifier exists, so we can represent as a implication sign. So that is the implication. That is the property. That is the note point. When a universal quantifier is present, so we can represent as a implication. Okay. So that is the important point. So you can note out in universal quantifier, we use you use implication. So you use implication. That is this. We use implication. So these are the things. Implication. Now see. So what is the meaning of implication? So in which condition implication is true? That is important. Okay, and which condition implication is false? That is important. So as you know, if true and false condition is given, so implication gives false. Now see, suppose I'm applying on like this one. Okay, so this statement, this whole statement, when will be false? Suppose P is a true and F is a Q is a false, then this statement is false. Otherwise, this is true. Even P is a false, Q is a true, that is true. Both are true, both are false, that is true. So these things we have to understand. अगर आपको ट्रुथ टेबल पता नहीं है तो फिर आप सॉल्व नहीं कर पाइएगा. So that is very important to remember the truth table of the implication and biconditional, that is called the if and only if. और इसे बोलते हैं if and then. Okay. So आपको बहुत याद करना बहुत जरूरी है. Inference rule and ये this tables, that's the logical connectivity table आपको पता होना चाहिए. Suppose I am going to write. So best example, we can say that all over world, in every book we can follow, and every site we can follow. Uh, all man, all man, sorry, drink coffee. So these are the universal. Okay, all man drink coffee. All men drink coffee. So how can write universal quantifier? That is important. So now see, here we can assume that, what can I assume? Here we can assume that this is the X. Okay, we can assume man is a X. Okay, and drink we can understand that is a relation. Okay, that is a function we can drink. Okay, now here I am going to write for all man X. That means for all X. That means for all X. All I am going to write this one. So this one I am going to write for all, and for man I am going to write X. Okay, and after that I am writing a man represented as a function of X. That means this man represented as X. So whatever the value 1, 2, 3 represent man. And this is the use the implication, as you know. This is the implication, as you know. This represent as an implication, and we can write a relation. Always relation outside first. So I am going to write a relation drink, drink, and what drink? Drink कौन पी रहा है? Man पी रहा है. So what is the man function? X, and what is the rating? Coffee. That is the object. Okay. तो इसका मतलब क्या हुआ? फॉर ऑल मैन, जो मैन क्या है एक्स है, वो ड्रिंक कर रहा है, क्या मैन ड्रिंक कर रहा है? So that is the meaning. That is the example we can follow. So these things are we can follow. Okay, for the universal quantifier. Okay, so most of the time you can use all the things. So don't worry, we can perform the numbers of questions on a feet. When we can cover all the examples, sorry, theoretical part, then we can go for the example. The best example, we can solve the previous year GATE questions, quantifier. Okay, so we can see the previous year GATE questions, then we can understand this type of questions. They will asking you a statement 1 and a statement 2. All gold are cost are like that one. They can frame the questions. So these we can practice on the things for universal quantifier. Additional quantifier, that means we can say therefore something. So we am going to write same process. Additional. Huh? Huh. Additional quantifier. So the symbol we can represent as a opposite of A, that is called a symbol. So we can represent as a distance simplifier symbol. Okay, and it can be always represent here. Now here in the universal quantifier we can use the implication, and the additional quantifier we can always use and or we can say that conjunction. That means what is the meaning of conjunction? We can say that this one. Okay, so आप and भी use कर सकते हो और conjunction भी. So that is the intersection. Both are. And का मतलब भी intersection होता है और conjunctions का मतलब भी intersection होता है. So basically this is we how to exist read. Suppose someone asking how to read. Now see here all X. universal quantifier, if you want to for some x, or we can read about for at least one x, for this is the way of reading. Okay, and last one, how can I study? There exists a x, we can say that. Okay. These things are very important. How to read the additional quantifier for some x, for at least one x, and there exists a x. Okay. On the basis of we can perform the task. So we can perform some boys are intelligent. Now some boys are intelligent. ओके, नाउ देखिए यहाँ पर हमें समझना ये है कि यूनिवर्सल क्वांटिफायर को हम लोग इम्प्लीकेशन से डिनोट करते हैं, और यहाँ पर जब भी हम बात करेंगे एडिशनल क्वांटिफायर को, तो वी कैन गो फॉर द इंटरसेक्शन. तो सम बॉयज आर इंटेलिजेंट, मतलब हमारे पास बॉयज हैं और सारे बॉयज हैं, लेकिन उसमें से कुछ ही बॉयज इंटेलिजेंट है, तो कॉमन आ गया ना, बॉयज और इंटेलिजेंट का इंटरसेक्शन आ गया. तो ये आपको लैंग्वेज के फॉर्म में समझना होगा कि हमें यूज कैसे करना है. ओके, इंटरसेक्शन दिया हुआ है कि नहीं. सो दैट इज कॉल्ड फैक्ट्स एंड रूल, इन्फरेंस. वी कैन फाइंड आउट द इन्फरेंस. So suppose I am writing some boys are intelligent. So how to write some boys? Same process. I am going to use therefore exit x. That x exists are some boys, that x boys, and I am writing boys of x, and I am using this one, and I am going to use intelligent. Okay, now so who is intelligent? The boys is intelligent, so I am writing both x. Now here boys is represented as a x. So now see, आपसे कोई पूछ सकता है कि भाई आपने इंटेलिजेंट में x क्यों लगाया. क्वेश्चन ये होगा ना कि इंटेलिजेंट में x क्यों लगाया. ओके, तो भाई इंटेलिजेंट कौन है? लड़का है ना, कोई और तो चीज है नहीं, तो इंटेलिजेंट में हमें x लगाना पड़ा. सो दैट्स व्हाई दैट इज अ पर्पस वी कैन ऐड x. बॉयज तो x है, सो इंटेलिजेंट में x. Okay. So this is the way we have to represent. Okay. Additional and all the things. So बहुत important point है for universal quantifier you can use implication, and for the additional quantifier you can use a conjunction or and operation. Very important point. ये आपको भूलना नहीं है, बहुत हेल्प करेगा आपको क्वेश्चंस को सॉल्व करने में एआई के. नाउ सी, आप जो भी यहाँ पे लिख रहे हो ना, हमने जो भी आप अगर हम इस चीज को एक बॉक्स में रख दें और उस बॉक्स को हम लोग आपस में इंटरलिंक कर दें इस टाइप से, और इस तरह हम लोग एक आउटपुट निकाल कर पहुंचते हैं, तो इस टाइप के डायरेक्शंस को हम लोग बोलते हैं ग्राफ, और इसी चीज को हम लोग बोलते हैं एआई में कॉन्सेप्चुअल. Don't worry, we are going to discuss about conceptual graph. But conceptual graph is totally related to the first order logic, propositional logic. Now, how? Suppose whatever I am getting the result here, so same thing I can derive through boxes. Same thing I am going to derive through the graph. So that is called the conceptual graph. Okay, so that is the meaning. Don't worry, I am going to discuss about what is the conceptual graph and different type. So first we can cover additional logic, universal quantifier, then unification, then induction, deductions, then that is okay. So these things we are going to do. Now, so some points are very important. So these 2 points, the properties of that one. So always remember, this is very important. They will ask you first property. Suppose you can use the universal quantifier. Okay. Universal quantifier, and I am going to write like this way. फॉर ऑल एक्स एंड फॉर ऑल वाई इज इक्वल टू, आप ऐसे भी हो सकता है. ओके, that means in an universal quantifier of writing both two quantities then equal to both opposite. Okay, that is the commutative properties can follow. So that is very important. It can follow commutative. So now same process for the additional quantifier. Same, if x and y if you are writing, then you can writing like this one. Okay, so this one. So these are the very important point, because most of the questions they will ask you on the basis of this one, this 2 point. So these are very important. अगर आपको both अगर same quantity है तो आप x and y भी लिख सकते हो, y and x भी लिख सकते हो, कोई फर्क नहीं पड़ेगा, both are equal. सेम अगर आपका ये होता है थर्ड पॉइंट, अगर आपका ऐसे आता है और आपने ऐसे लिख दिया, सो ये इक्वल नहीं होता, ये इक्वल नहीं होता. होता कब इक्वल कब होगा, जब दोनों सेम क्वांटिटी. ओके, नाउ सो आप देखो इस चीज को, देखो आप इस रियल लाइफ में यूज करते हो कि नहीं इस चीज को. कहाँ, when we go for the marriages. See, see, everything is taken for the real life. Okay, so all the things whatever I am writing here in a computer science taken from the real life. Okay, so that is the scenario. आप सोच सको हमारे टाइम में हमारे ancestor how much they are intelligent. Okay, so these things are there. Okay, so we can use some examples. So all birds are fly. Every man has his a parents. All the things we can use. All the things we can perform. So these things are things. Now, so we are going to discuss about a free and free and bound variable. So these two variables are going to discuss, free and bound. So what is the free variables? The that variables are called a free variable that is occur outside the scope of quantifier. So out of a scope अगर quantifier का कोई use हो रहा है, so we can say that the free variable. So we can write here free variable. That means we can have a variable that is the out of a scope of quantifier. So we can say that it occur out of a scope of quantifier. So what is the out of a scope? Suppose I am writing for all x and for some y, therefore some exist of logic, we can create a relation x comma y comma z. Okay, now see here we can use the quantifier here using x and y, but we cannot using z. So z is called a free variable. It occurs out of the scope of quantifier. So here we can say that z is a free variable. Z is a free variable. That means the out of a scope. Now here see, this will be the out of a scope, because in quantifier we can use only x and y. Okay, and bounded variable. So as you know, bounded variable it occur inside the scope of quantifier. Yes or no? So अगर हम बात करें तो x और y क्या है? Bounded variable. That is the simple. So it can be occur within the scope of quantifier. So we can write x and y is a, क्या बोल सकते हैं आप? x and y are bound variable. Okay, so these are the one numbers questions. What is the free variable and what is the bound variable? So don't be confused by कौन सा variable पूछ दिया, कौन सी दुनिया का variable है. So when we are talking about free and bound variable in AI, so that means I'm talking about KB, knowledge base system. So always important what we are reading a study, which topic is all inside नॉलेज बेस नॉलेज बेस एजेंट के अंदर ही ये सारी चीजें पढ़ रहे हैं. ये नहीं कि हमारा प्रोपोजिशन लॉजिक अलग है, ये सब नहीं, ये सब नॉलेज बेस्ड एजेंट के अंदर ही आते हैं. ओके, सो is it clear? Anyone doubt online? No doubt. Oh, Vivek present? Yeah, Vivek, you can take attendance and can send me. Yeah, thank you, Vivek. And